Today we will review SecureXL. We will try to understand SecureXL basics, and also we will review some SecureXL troubleshooting commands. I think it is really hard even to start explaining what is SecureXL and why we need it on Checkpoint Firewall. I think the best way to discover this topic for yourself is to open Performance Tuning Administration Guide for R81 and then go to the SecureXL section. There we have all the topics to understand what is SecureXL. We will start with the packet flow. Okay. If you're working with checkpoints for quite some time, this packet flow is kind of self-explanatory, but if you didn't work with checkpoint too much, you may have a lot of questions. First of all, the goal for SecureXL as a feature is to accelerate processing of the packet flow and maintain security with this acceleration. To explain this traffic flow better, it is better to draw a little bit. Let's put this flow chart to the side. What we have in the beginning, we have a packet, and the packet entering the RX buffer of the incoming interface, and the goal of SecureXL is to put this packet straight to the TX buffer of outgoing interface and avoid any unnecessary firewall inspections and rule-based lookups. But to achieve this, first this packet should be analyzed by the firewall, and an entry should be present in SecureXL connection table. And if the entry is present, then this entry will have the inbound interface, outbound interface, and firewall can see that indeed we can put the packet straight from RX buffer to TX buffer, and this represents the fast path, the accelerated path. It is not so easy because when it is the first scene for the connection, when we have just the first scene, this scene does not have yet any entry in SecureXL connection table. And for this scene, we will have to go through this not found path and arrive to the CoreXL dispatcher and firewall instances. What is the CoreXL dispatcher and what is the firewall instances? CoreXL dispatcher, also called security network dispatcher. Security network dispatcher is a specific feature which helps firewall to decide which packet should be worked by what firewall worker instance, this firewall instance, and in output of CLI commands we'll see it as a FW worker. To demonstrate it, I will open the SSH to gateway number 1. In gateway number 1, we can use command fwccl affinity -l -a, and it shows us that security network dispatcher can use any core, any CPU core, to decide which firewall worker will analyze the packet, and then firewall worker can use only specific cores to make a firewall decision. Let's summarize this a little bit. So when we have a packet arriving to the RX queue of an interface, then firewall should decide what to do with this packet. For this, it has an SND. SND looks into the packets in the RX buffer, and then SND asks CPU time to make a decision, and then SND tells that this particular packet should go to this firewall worker instance. For example, it's firewall worker 0. Firewall worker 0 will ask very specific CPU. In our case, firewall worker 0 asks CPU number 3. For some CPU time to process this packet through firewall policy and all the inspections. And the original packet original packet is still occupying some memory in the RX buffer, and this is just a copy of this packet going through the SND firewall worker and further firewall processing. So each new packet arriving to RX buffer takes more memory in the RX buffer, and each packet takes more and more CPU time to be processed by SND and by firewall worker. When we do a top command, if we do a top command, we remember that we have this system space CPU, and we have this system space interrupts. And if we go back to our drawing, SND CPU is SI from top command, and CPU3 for firewall worker is SY from top command. This way we can easily say, for example, if we have really high SY here, means that firewall worker takes more CPU time, and this causes this counter to go up. If we have in output of top command SI is high, this means that this CPU time was spent by SND to decide which firewall worker should work which packet. Next step for the packet is to go through inspection chains in the firewall instance. As soon as security network dispatcher selected the firewall worker instance, then this firewall worker instance will take this packet through all the inspection chains. To see the inspection chains, we can do the command fwccl chain, and we see that it is 28 steps for inbound packet and 21 steps for outbound packet. We see that the first 9 steps is related to SecureXL, as well as the last 5 steps also related to SecureXL. If we are able to use SecureXL in full acceleration, then basically packet will skip a lot of steps for the processing, going straight from RX buffer to TX buffer. After going through inspection chains, we are getting to the step to see if we have any connection templates. So templates may save us a little bit of a CPU time, because if template is found, we can open connection from the template. If the template is not found, then this packet will have to go through the rule base and wait for the firewall worker to decide if this packet should be allowed or dropped. We can easily check if we have some templates in SecureXL template table. For this, we can open our firewall again and do the command fwaccel templates. And as soon as we don't have any ongoing connections, we have this table empty. Means that in our case, we will go for the right, and templates are not found. If the templates are not found, then the packet will go through the rule base, then it will arrive to the next decision. So select the SecureXL ID on one of the cards and afford to SecureXL. And then that's a big question if we can do it or not. If we can do it, then we will go to the left. And if we cannot do it, then the packet will go to the slow path for additional inspections. Usually slow path means that we will have to go through some additional IPS inspection, or we have some HTTPS inspection, or we have some additional blades like anti-bot, antivirus, data leak prevention, or application control. And in this scenario, then the packet will have to go up, and after that, it will arrive on the outgoing interface TX buffer. And this step to go through this slow path usually takes the most of CPU time to process the new connection. If we are lucky and we don't need any additional inspection to happen, then we of course taking the faster path. We arrive again to the SecureXL connection table reevaluation. If this connection now present in the SecureXL connection table, then we will go straight to the TX buffer of ongoing interface. We can now check how content of these tables change in real time when we initiate the test connection through our firewall cluster. Let's open a number of SSH sessions. In this window, we will see how connection table entry creates with the fwcctl on tab minus source IP equal to 192.168.43.1 and destination IP equal to 172.16.1.100 and destination port equal 22. Right now we shouldn't have any connections like this. We will add watch command for every second for this command here, like this, and to let it work for us a little bit, we will put it to the side. See, it is updates every second to show us the new connections. Let's open another one. In this window, we will monitor SecureXL connection table with fwaccel tab minus T connections. Right now this table is empty. We will watch it with minus N1 minus D and then this command. Okay, let it work for us in the background. Put it here. And we will need another SSH session to look for templates. To look for templates, we will use fwaccel templates. Right now we don't have any templates. We will watch this command minus N1 minus D fwaccel templates like this, and we also put it to the side. Now we can open the test connection to the lab SMS through Ethernet 1. Immediately we see that connections were created in all the tables. We have one connection in the connection table, we have one connection in SecureXL connections table, and we have one template. In the template we see that any new SYN packet from this source to this destination by this destination port will be going through the connection templates. It will not go through the slow path. It can use the connection template. We see that in SecureXL table we have one connection, this one from source to destination by port 22, that's TCP, and also it creates another template, another SecureXL connection table entry from server to the client. And here we have interface indexes. We have interface indexes for client to server connection, and we have interface indexes for server to client connection. Using these interface indexes, SecureXL can understand which is the incoming interface, which is outgoing interface, and it can direct the traffic flow straight from input to output interfaces. Let's continue and log in. We see that when we logged in, it updated the timers for the connections. Also, we see that we have the template expired. If we will exit and then we open another one, immediately the template is reappearing here, and we see the timer that it's 1 minute with a half per template. If no new SYN packets for the same source destination port, the template will expire again. Okay, we can close this connection now, and let's stop all these commands in the background. It is worth mentioning that SecureXL acceleration can be divided in two main features. The first is the throughput acceleration when we are taking this path, and throughput acceleration usually is active for all the packets after the first SYN packet. From the other hand, we have the connection acceleration. Connection acceleration happens when connection template is found for a new SYN packet. And when we take in this path, this is the connection acceleration working. So just to repeat, if we have the first SYN packet, we will never take this path. Never take this path because it will have to go through at least new SYN packet will have to go this way down to this decision maker. Then this decision will be done if it is SYN packet matching some already existing template, then it will turn left. If it doesn't match any existing template and it will create a new template, it will go right. So only for the first SYN packet we can see effect of connection acceleration. But in case if it's not a SYN packet, if it is something else, for example, it is another packet, let's say if it is some push packet, and this push packet match already existing SecureXL entry in SecureXL connection table and can take the fast path and go straight from inbound to outbound port. So now when we understand the basics of SecureXL, we can review some. Now when we understand some basics of SecureXL, we can review useful SecureXL commands in CLI. We can open our gateway. In the gateway, we can check command fwaccel stat. fwaccel stat shows that we have SecureXL enabled for SND. This refers to the throughput acceleration, and also we have accept template enabled. This refers to connection acceleration. We have drop templates disabled, and we have net templates enabled. The other command is fwaccel stats -s, which is very high level statistics about SecureXL. What we want from SecureXL is this counter to be as close to 100% as possible, means that this is the ratio between accelerated packets and total packets. This represents the counter for throughput acceleration. From the other hand, we have accelerated connections and total connections ratio, and this represents the connection acceleration ratio. We want both of these numbers to be as high as possible. For our test firewall, these numbers are really low because we don't have any connections going through the firewall. Most of the connections we have are going to the firewall itself. And if the traffic is going to the firewall itself, it is not subjected to SecureXL because anyway, all the packets should be processed by the kernel of the firewall. What we also should look at is F2F packets. This is the number of packets going through the slow path, and most of the packets on this firewall are going through the slow path. To demonstrate it better, we can watch this command. We can watch -n1 -d and then the command like this, and we have the counters. We see that these counters for F2F is always increasing because this is the packet we are sending for our SSH session. But if we will open the test connection like this, we immediately see that these packets are taking accelerated path because these packets are going through the firewall and taking a fast path. We will got the SecureXL connection stable entry. We will have a template, and all the subsequent packets for the same TCP session to our SMS will go through the fast path. Another useful command would be the same fwaccel stats, but with a -p, which will show us all the packets which will sent not through the accelerated path but through the slow path. This command is useful because usually if we have a problem with SecureXL means that some packet doesn't go through SecureXL for some reason, and we need to find out why the packet didn't go through SecureXL. In this case, we will take a look at these counters. There are many categories. We should notice which category is increasing when we initiate the connection. We will try to do exactly this. We will watch this command. We have the counters, and we see that cluster message is increasing. That's our cluster XL sync messages, and this TCP are the misconnection. This is the packets of our SSH session. That's the two reasons why packets are taking slow path. If you want some more information, we always can do -H to get help and see what else can be useful for our troubleshooting. For example, we have a drop statistics. Let's see what we have in drop statistics. We have all zeros because nothing was dropped by SecureXL. If we have some problem with SecureXL dropping packets that we want to understand more for the reason of why it is dropping packets, then we will have to look for these counters and most probably create a checkpoint tag case to investigate further. We already reviewed the previous commands to check SecureXL connections entries. This SecureXL tab -t connections -f to format the output. Now it's empty. If we initiate a session, this output will not be empty anymore. We will have entry from server to client. We will have entry from client to server. And what's more important, we have indexes of inbound and outbound interfaces. The other one is fwaccel templates. It will show us the templates. Here we also can see the indexes of the interfaces from the previous output. So 1 corresponds to Ethernet 0, 2 corresponds to Ethernet 1. So that's the templates. SecureXL problems usually are related to two main issues. First is SecureXL dropping packets for no reason. For this, we can troubleshoot with this command. And the other, SecureXL does not accelerate some connection which should be accelerated. For this, we can use this output. In case if neither of these commands help you to identify a problem, then you will need to run a SecureXL debugs. But SecureXL debugs will be part of some other video. Today we reviewed SecureXL. We checked in real time how SecureXL connections table entry creates and how template entry creates when we initiated the test connection through our firewall. Also, we checked some basic SecureXL troubleshooting commands, and I hope now we understand better why we need SecureXL on the checkpoint firewall.